Hey everyone, thank you for joining. I just wanted to get started and introduce myself. My name's Mason Kresge. I'm a business development manager at Occipital AI, and I'm here to talk about what's holding back widespread adoption of AI in manufacturing. Just to give you a brief overview of who we are, Occipital AI is built with about 40 individuals. We are located a bit north of Boston in Bedford, Massachusetts. And we were formed in 2016 with a group called Soft Robotics. You may have heard of them. They have the blue fingers. But we split off in 2024 to focus primarily on the AI vision and transforming manufacturing. With Soft Robotics and Occipital AI, we've been working in the food space for the last 10 years now, and we recently focused on AI-enabled machine vision. We understand that food has so much natural organic variability, and traditional rules typically struggle with that. So that's where we see AI really shine. So, what is holding back the adoption of AI? I mean, I think it really lands into three different camps. So, from one, it's just the barrier of entry to train the system. AI is not as easy as people make it seem. So, people will be sold on a really simple application and it just doesn't work as they expected it to. Two, manufacturers are terrified of what people refer to as the black box. Uh, People just like control with their system. So having that loss of control really scares a lot of people. And three, it's hard to really determine what the value is, even though everyone seems to want it. But for each, I will go into the details. So training. I think everyone here has seen AI, seen what the outcome is, and they all think and have seen demos of the we only need 10 images, right? It sounds great. Some people have even given it a try, but what ends up happening is I kind of see whack-a-mole happen. So what you'll see typically is you'll take a few images, you'll hand label them all. Think of the reCAPTCHA to prove yourself a human when you go to a website. It's kind of the same thing, just a bit more time consuming. You have to be very accurate with how you draw around your objects. But this process typically isn't this 10 image and it's done. You have a beautiful working model. What people don't understand is it actually typically takes a lot of time. What you'll do is you'll go around and you will draw on hundreds of these, maybe even thousands, depending on how complex the problem is, and you'll need to label if it's good, if it's bad. So in this case, you would have to label the good corn, the bad corn, the ones that have husk, the ones that have damage. And what is really interesting is we're not consistently disciplined. So imagine you're doing this when you're quite energized in the morning on a Tuesday versus it's a Friday afternoon and you're just trying to get home. You start to get a bit sloppy, and that sloppiness really carries through your entire model. So I would ask yourself, are you really going to be consistent with this labeling? But assuming you were, and you went through all of this and you did it perfectly accurate, the next question is, what happens if someone walks by a maybe a light starts to burn out, your lighting scenario starts to change. And if this is outdoors, I mean, think about a sunny day versus a cloudy day. This lighting change could really take a model that works great and change it to something that just doesn't work. And you see this in AI-enabled vision as well as traditional machine vision. But if you only label your images off of these, what I would say, your expected scenes, the second it starts to deviate, you start to have these issues. So, how do you enable AI to have this widespread adoption we're all looking for? Well, from the manufacturing customers I work with, it seems to be they need a really easy and accurate solution. So instead of being burdened with this labeling and training, what if you had a team of engineers who are already trained and they were specifically AI ML engineers and they'll deploy a system that's ready for the customer? Instead of doing all of that labeling, which can be very error prone, why not have a team of experts do it? And why stick with a 2D image when you could have a 3D scan of your product and you'll have even more information to work off of and more variability? So with 3D scans, your synthetic data can be generated very quickly, and you can also build in all of the different environments. You can build in different lightings. Think of, once again, the light burning out, or something that people don't really think about. You have a damage in the belt, your maintenance team does a quick change, and now instead of having a blue belt, you have a blue belt with a section of black in it. All of a sudden, when you have these images being taken in the black section, it fails because it's expecting a blue background. With synthetic data, we're able to put this through tons of different lighting variety, making sure that that light, the shadows, and those belt differences don't ruin your object model, and you'd have to go back and relabel everything, take a bunch of images, and do that tedious process of drawing all those images on, which I'm sure you were tired of doing at that point anyway. So simply put, the burden of the training needs to be with the experts. And while it might be attractive to do it yourself, it's typically a harder process than what you're expecting to get into. So the next factor is really the black box. It's this scary term that gets thrown around quite a bit, especially with pre-trained solutions. It sounds great to have something out of a box, but what if that training isn't exactly what your team needs? What if the definition of good and bad differ for what it was trained for? Well, that's kind of the heart of the issue, right? If it's pre-trained, there's typically no flexibility to even tweak much of anything. So you have good, you have bad, you have cat, you have dog. There's no in between, and there's no subjectiveness, what you see in people. Some systems might enable that additional customization, but in kind of what you expect from what I've been discussing, you label more images, and uh, you can already kind of get the idea that it's not really a feasible and viable solution as you have to label more and more images just to make this thing work. And as you're training it with these images, maybe the things that were working good no longer work as well as they did. So you're going back to that whack-a-mole. What you really need and what AI needs for this adoption is really easy to understand rules and criterias that give people the flexibility to have the model look at it, but not necessarily tell them what the exact issue or if it's good or bad right out of the box. People typically have a subjectiveness to it, and we just need to make sure it's consistent and we have that built-in tolerance level. So think about training an employee to identify something like, I don't know, corn dogs. You don't necessarily need to teach someone what a corn dog is or the size of the corn dogs or what it's quite looking for, but you do spend quite a bit of time going over what constitute good versus bad. You don't necessarily want to reject anything that has a small little scuff. Some customers might be willing to accept that. Others might need to have some sort of rework built into that. But you can't have the system just automatically call it good or bad. So these people, what we've seen, have some defects have strict tolerances, others have a bit more leniency to it, depending on the application and the customer. You'd also tell the employee what to do with the bad products, what to place them, what dictates work versus trash, right? If an application isn't working the way you want, you simply do a bit of training with the person. You tell them the good, the bad, but they don't need to relearn everything from scratch, which is what you see in typical AI applications. So what we do is we will enable someone to have these rules, and rather than having it hard coded, you simply change the configuration of what the model is looking for to determine what is good or bad. And it makes it really simple and not so hard coded, what you see in a lot of applications. And I think really the third and final factor that prevents adoption is really the bottom line is, how does it make me money? Uh, what justifies me paying for this, right? A lot of AI has been put into the world, and I'm sure as you go around the stage and you walk around the show, you're going to see AI everywhere, right? And especially some venture capitalists have thrown, I mean, oodles and tons of money into it, but it really hasn't seen the adoption versus the investment in manufacturing because no one's found a great way to really generate the funds back. AI definitely makes things easier for employees day to day, right? We think of ChatGPT making emails easier and how to format things and how to speak and how to say things. But while that's a savings, we don't really see it necessarily on the vision. So what's causing this money to be brought back in and justify the investment? A key component is showing people just how much money they can save by implementing a system, right? A lot of our experience, if you saw some of our investors, is with the food, right? COVID really drove us into that space, and we're seeing a lot of activity. So think of something as simple as a pizza, right? You add in sauce, you put on some cheese, and you add some toppings, maybe pepperoni, right? But if you notice something with the crust or the dough, would you necessarily add all of those toppings, or would you rather save it for something that's good and not waste the resources doing the bake and the actual components itself, right? All those toppings would go to waste if the crust wasn't good. Machine vision has been used for final checks, but in manufacturing, it can be leveraged in the AI just by looking at things at each step or just upstream, right? They can prevent defects before they even happen and areas to improve. So just because you don't necessarily see the issue happening at that moment, maybe you can correlate to something that's going upstream. Think of if your crust is underbaked or it's burnt, you can see that the defects are coming in, and that's great so that they don't reach your customer. But you can see those trends and determine what's going on and maybe make an adjustment to the system, like the belt speed or those oven temperatures. And it has to really be in an easy to digest format that really inspires people to not only look at the data and improve and understand those processes. So just to recap, I think it really falls into those three camps. So I think it kind of makes sense, right? If training is simpler and easier and it just kind of works out of the box, people are going to be more accepting to it, especially if once it hits your floor, you're able to handle that variability. So those experts trained that model up for you. It has a complete understanding of the three-dimensional object that is presented. And once it gets to you, you have the flexibility to be able to adjust the parameters rather than just having it be good or bad. It needs to have some form of tolerance built into it. And really, the third is just to be able to see how the value is built, whether it's to go back to a supplier if you're receiving bad products, or it's to simply do rejections, right? You need to see that data in an easy to visualize format so that you can quickly make adjustments and get an idea of the trends and what's working on your line. Well, thank you for sitting here and listening to the talk. If you get a chance to come visit us, I would love to chat. Otherwise, feel free to connect with me on LinkedIn. Shoot me an email if you have any questions, comments about the presentation, or you just have an interest and want to learn a bit more. But otherwise, thank you for coming to the meeting. I appreciate it. Bye bye.